Can everyone see
Okay,
my
great.
screen?
So, yeah, everyone can see your screen. So, real briefly here, everybody, this is Craig Garachi. He is a product leader. He's had stints at Microsoft and Amazon, real expert in the software development lifecycle, how AI fits into it. And so, we're really excited to have him here today. He's got a great presentation. Craig, I'll turn things over to you. And I'll kind of I'll jump in if people have questions along the way and kind of facilitate those. So if you have questions, raise your hand and or just say something, and I'll just kind of relay things because of the microphone and all that. So, all right,
Okay.
Craig, over to you.
Well, thank you. I appreciate the opportunity to present and have a great discussion today. So today, the big idea I want to present to you, it actually grew out of meetings that I was having with both program and product managers. And it can kind of be summarized as the following: that we have stakeholders that are very, very excited about AI and certainly ML over the past couple of years. And their requests kind of boil down to, hey, add AI to your next release. And PM is hearing this, they're receiving these requests. So from a stakeholder's perspective, it looks fairly straightforward just to add AI to your next release. But PM is saying, well, it's a little more complicated than that. It's not so easy just to add it as another, feature area. They're rightfully raising a lot of very good questions. What they're saying is, what about the value that adding AI to the product, what value does it really bring to the customer? So of course, continuing to work from the customer back. And also, are AI products built differently than products without AI? And then where do they even begin? How does the overall process differ? Where's a good starting point? So these are the main questions that we're going to go over today. The agenda, more specifically, is to extend your experience building regular software products to build products with AI. So conceptually, you can kind of look at it as, if you're experienced building products without AI and ML, what we're going to do is just build on top of that and extend that knowledge and experience today. And this doesn't mean that products with AI are twice as large. It just means that we're going to extend your prior experience. And in order to facilitate that, we have a generic software development lifecycle, and it's process agnostic. So if you're using Agile, Scrum, Waterfall, whatever, you should be able to reuse it for that. And the SDLC that I'll show in a minute here actually calls out where that unique AI work could take place. And just a little more of focus on the agenda, that I don't want you to assume that I'm just skipping over things, but engineering systems typically have three parts. So of course, the people, the developers, other engineers, if necessary, data scientists, UX, CX people. Those are all the skills and experience, the people that actually build that software. The tools, of course, are anything to manage and build the source code, to deploy to different environments, operational tools. Today, we're going to focus on the process through this generic SDLC. And if we have time, we can talk about when is AI really kind of ideal to be added? What are the main benefits that could be used to add that to a release? And also, how do we go about picking the right project? So we can talk about that later. Disclaimer, because I don't want you to assume that this is paint by number, because as you know, software projects just in and of themselves are unique. So this is for informational purposes. You can use it at your own discretion. And also because different projects, and certainly projects that have AI that process data, customer data, demographic data, you may have to rely on the help of other professionals like legal, privacy, security. And then some background really quick on who I am. I have over 30 years experience in the software industry. I started out as an SDET, the software design engineer and test. So I actually wrote code to test compilers, assemblers, and runtime libraries. Beyond that, I've held various product and program management positions. I worked at Microsoft for 21 years, and I worked at Amazon for 6.5, and I worked at 2 different startups as well. I'm the founder of my own business. I offer career coaching for technical project, program, and product managers. And I've been working hands-on with AI and ML since about 2015. And you're probably aware that there's a lot of different applications for AI and ML. But the area that I fell in love with is natural language processing, just because it's so challenging trying to get meaningful, insightful information out of unstructured text. So that's an area that I love. And I've led teams both with data scientists to build products that have AI in them, deployed those to production. And I've also created my own models and retrained existing models and had those deployed to production. And in both cases, those achieved measurable customer benefits. Just some definitions that I'll use consistently throughout the presentation today. A project has very specific start and end dates with very specific goals. After that project successfully completes and it's released to production, that's when it becomes a product. So if you've ever heard about like Windows 11, well, that was a project at one point. It's released that then extends the Windows family, for example. The product, I define this to be fairly broad. It's really almost anything to fulfill that business opportunity or customer needs. So just some examples. A product could be a standalone application, a set of APIs. Products with AI could be like an online ad system necessary to surface relevant ads to the customer, or even fraud detection that's used within companies to determine, is customer fraud being committed. An SDLC, software development lifecycle, is just a conceptual approach to logically group activities that are necessary to manage a project within those constraints. And it can be used with any type of approach. And then lastly, I define customer to be fairly broad. It could be the external paying customer, but I also use it today to include the internal user within a company. And I do that because I know that there are program managers who are focused on delivering solutions within a company. So for example, fraud detection that's used within a company. So I just want it to be inclusive of lots of different types of program and product managers. So with that, I'll pause just for a second to see if there's any questions before I give an overview here. Are there any questions?
Anything at this point? All right.
Okay.
All right, let's feel free to continue.
Okay. Just some important notes here. So the life cycle, I think that Josh distributed a PDF file that has all the boxes and under here fully expanded.
Yeah, that's it's in the slides we'll make available. So if you scan the QR code, I still need to update the slides with that. But yes, they'll have access to that for sure.
Okay, cool. So the SDLC that I'll show here, it doesn't suggest any project management approach, Scrum, waterfall, whatever. And I say that because as soon as I draw boxes with arrows, people immediately assume that it's waterfall. It's not. I'm not proposing any type of project management approach. This is just a suggested overview to think through what would take place in your own AI projects, and you can use any project management approach. The supporting activities and work items, those could overlap and repeat if necessary. And also, I previously released this under the Creative Commons license. So if you wanted to use this for your own purposes, you're absolutely able to do that. Let me first give just a horizontal overview first, and then each of the slides will be associated with each of the boxes on the bottom here. So overall, in order to extend your experience working on regular software projects without AI, and to extend that experience to working on projects with AI, what I've essentially done is a diff. So if there's any boxes that are just a clear white, these are things you would normally do on any software project. But if they're unique tasks or unique things that are necessary for an AI project, I've called those out with the blue boxes. So let's just dive in here a little bit. Really, any software project starts with identifying that opportunity, and I'll give some more details in a minute. And of course, that opportunity could be just a couple of sentences, but then it's necessary to actually dive down and understand who is the customer, what are their stated and unstated needs, what's kind of a typical day in the life, working forward from there. And then building a business case to actually justify, why we should go about building this particular project to satisfy those customer needs. After that, working on detailed requirements and performing active development. And then beyond that, there's really two outcomes: that the overall project itself has met its release criteria, and the AI model or models are able to meet a particular level of performance. And I'll give examples of those later. So in that case, both the overall project and the model is ready to go to production. That's success. That's what we all hope for. But there's this other potential outcome, because there's a lot of experimentation that goes into, building and testing and evaluating different ML models, that it's likely that those experiments could fail, and they may never achieve the intended result or the threshold. So when I mention this, because there's a lot of online courses and different types of meetings where they'll give you fresh, clean data, and it's fairly easy to get a successful result. However, in the real world, there's lots of dirty data, there's lots of dependencies, your data pipeline, there's different outcomes that could be achieved. So I wanted to focus a little bit on what to do if you have repeated model experiment failures. So that's just an overview there. Are there any questions on the overview so far?
I'm getting a lot of head shakes, no questions, but a lot of looks of comprehension. So feel free to continue.
Cool. So the bottom boxes are now the index at the bottom here. So as we move through, they'll change color. So as we discuss details, where that aligns overall. So again, this is a box with a clear header. So we're not going to spend much time on this, because this is what you do on any software project. So the opportunity could come from management top-down goals. Like management could say, we're going to reduce customer churn by 10% over the next fiscal year, or we're going to reduce internal operating costs by like $100 million over the next fiscal year. That could be a top-down management goal. It could also be bottoms-up opportunities identified by the product team and program management. They could always identify better ways to serve the customer. In either case, these are just high-level statements. There's a lot more detail that's needed. And of course, this is very early stages. You want to keep all of your implementation options open. You may not even need AI to meet your goals for this opportunity, or it could be added in a later project. After that, you're going to dive down more into needs identification, further defining that top-down or bottom-up opportunity. And I have just a couple examples over here. Some of these may look familiar. There's other things you're probably doing at your companies to identify customer needs. Of course, this includes high-level items, determining who specifically is the customer, and also some items later on, like cognitive walkthroughs or usability testing, where if that project is farther along and you have a solid user interface, you may do usability testing, make sure that the customer can achieve their goals. After that, building the business case. And again, the main point you want to answer here is the project worth the investment to meet that opportunity? And this is really where you want to start asking, do we really need AI to meet that opportunity, to fulfill that opportunity, and when? Does it have to go in this release we're planning now, or could it go into a future release? If it's decided that AI is really needed in this release, and it's really a conversation between PM and data science, or PM and data science management. If data science is needed, then that's additional resources, additional items to add to the overall schedule. And also there's a conversation around humans in the loop. So there's two types of humans in the loop that are typically involved with some AI projects. One could be just getting feedback on the predictions or the outcome that the model has provided, and getting feedback from real customers. The other type of humans in the loop is actually having a dedicated team to actually go and audit a set of results, and to provide kind of a human baseline or a gold standard against which the model predictions will be compared to determine how well the model is doing. And those types of humans in the loop are known as taggers. Generative AI and large language models, they're known as prompt engineers. They could be an external company that may be needed to actually do that work. The humans in the loop, the taggers or the prompt engineers, they're used during experimentation as the model is being created, but also even after the model is in production as well. So that could impact your budget estimate, and also there's additional tools that I'll talk about in a minute. After the business case, let's say that's approved, you've assembled your engineering team. whatever you do for software requirements. Again, this is a clear header. I'm going to go over this pretty quickly. If you're using Agile today, this is your backlog with epics and user stories. Or if you're using large business requirements documents. For AI and ML specifically, this is something that's specific for requirements. So this is in the case where you've decided that AI is needed in the product. And we'll go over just a couple of key points here. There's a number of points, but I'll go over just a few of them. A large area is bias, and bias it refers to a model that is not representative of the larger population in which that model will make predictions after it's been deployed to production. So there's certainly requirements for data science to take into account that they're using data that's evenly balanced across all the different areas that are necessary to make predictions in the future. An important requirement is the model evaluation metric. And different types of models will have different types of metrics. So if you have classification models, like sentiment analysis is a type of classification because you're classifying comments as either positive or negative sentiment. Other types of models are doing predictions against time series data, like whether it's weather data or stock market data, other types of long-term running data. So that evaluation metric actually relates back to the business case. If it's customer churn, there's a certain metric that you want to have to ensure that your model performs at the right level so that you're reducing that customer churn. Related to the metric is the threshold. So this is that threshold that the model has to meet before it can launch to production with the rest of the product. So I just chose, a metric like the F1 score, and for today, I'll just refer to that as, 0.75. But these are requirements that are necessary for data science to actually go about building and evaluating the model. Beyond that, there's requirements for ML ops, and this is necessary for data science or ML engineers after the model has been deployed to production to ensure that it's up and running and healthy and it's processing data per the requirements. If it's decided that humans in the loop, specifically those taggers or prompt engineers, are necessary, and there's additional requirement to actually build tools for them to actually receive a set of predictions from the model to go about tagging, and then later to have those tagged results compared to the predictions to determine how well the model is performing. So those are additional requirements areas, and there's a number of them here that are additional areas to consider. So I know that's a lot of information, so I'll pause here just for a second to see if there's any questions.
Any questions here? Have people encountered any of these elements of their requirements on projects that you've been working on internally? Yeah.
I wanted to comment on the monetary cost.
Yeah, please do. We have a comment about the monetary cost.
And I think this is very interesting. I just saw there was a news article about some doctor that was killed in Minnesota on a road somewhere.
Okay.
And the driver, they think they found the driver says, "Oh, I don't know. I was using my self-driving."
Okay.
So now the vendor, and this is why we don't have self-driving tractors, because we could have had, I have a farm and we could have had self-driving tractors 10 years ago.
Sure. Yeah.
Here knows the liability. Farmer is the liability.
Yeah, absolutely. Craig, did you catch any of that?
I caught part of it. Are you able to summarize the question? I heard about driving and things like that, but I didn't hear the whole question.
Yeah, so just the idea that a person was struck and killed, unfortunately, and the driver had said that the assisted or the automate or the self-driving feature was enabled, and that was now the companies who manufactured it came into play, and then there was a further comment about we have some of this technology, could have self-driving tractors, but we don't, and this is one of the reasons why. Did I capture you? Yes. Okay, great, thank you.
Yeah, so definitely, yeah, the monetary costs, it depends on the type of model and how that will be used in the real world. So yeah, if there's humans involved, that monetary cost could be astronomical if the model fails. Other types of costs, Like if you're considering a model to predict customer churn, and you are giving, let's say, $10 gift certificates to kind of, for goodwill for that customer, but the model is providing false positives. It's saying that a customer will churn when they're not, then you're actually granting a much larger number of those gift certificates than you actually need to. Yeah, so there's lots of different types of monetary costs, so those do need to be considered as you're building the product.
Perfect. Any other thoughts or comments there before we move on? All right, back to you, Craig.
Okay. And then software development. So again, this is a clear header. I'll go very quickly over this. This is just traditional software development, design and architecture. And again, I'm not suggesting any approach. You could use iterative design and development, or, big design up front. Whatever you do for development, that takes place here. This is the area, model development. This is what everyone talks about. A lot of the publications you see, a lot of the different meetings, it's all about the model and the algorithms and the math. The model is the star of the show. But I think you can see that that actually takes place fairly far down in our software development lifecycle. We've already determined the business opportunity, who's the customer, we have our business case, we have enough requirements, and data science is able to actually go about leveraging all of that prior information to now start developing that model. And this is where data science leverages their prior needs identification, requirements, and if there's any constraints on the release overall. So are there like a fixed deadline where that release has to go out? They'll take all those constraints into account. And in general, what data science will do here, they will acquire and explore that data, look for bias to ensure that it's unbiased data and that it's clean enough and that they can actually convert it and actually have the model learn from it. And then overall, they're going to run a series of experiments to try and meet the model evaluation metrics. So again, the prior one that I had earlier, F1 score 0.75, that would be, in this case, the evaluation metric that they're trying to meet. After that, let's say that, one of the successful outcomes is that the project met its release criteria and it's ready to go to production. That this is where you have typical DevOps that's watching the overall health and state of the product in production. And depending on the architecture, the model could go with the rest of the product or it could be deployed separately. But this is typical software release. I'm not going to focus on that too much. For operations for ML, this is actually taking care of the deployment and also the overall health monitoring and the maintenance of that model in production. So this is determining if the model is actually processing data per requirements. So for example, if the requirement was to process data in a near real-time manner, is it really processing data that quickly? Or is it processing data on a particular cadence, like once an hour, once a day, once a week? Is it really processing at that cadence? And then related to that, that prior model evaluation metric will likely become the model retraining threshold, because after the model has been trained, it's released to production and it's going to receive brand new data it's never received before. And there's this thing called model drift, which is actually an umbrella term. It includes different types of drift. There's like data drift and concept drift that could occur. And let me give a quick example here. So let's say that from an operations perspective, we deployed our entire product to production. And at first, the model is deploying well above this retraining threshold. So again, in our case, that was the F1 score of 0.75. And then something happened after that, that the real results compared to the predictions, that it's actually falling below that retraining threshold. So another requirement is that if the model is performing below the retraining threshold for some period of time, let's say 2 weeks, then it's considered to retrain the model. And model retraining is actually kind of an umbrella term that it actually includes anything that feeds the model. So you want to look at, were there changes to the data pipeline? Were there changes to how feature engineering is done? All of that information is fed into the model. Did that change and actually degrade the model's performance? And if so, you want to check into all those different factors and determine, to actually retrain the model to bring it back up above this retraining threshold. But that's one example of what would be on an operations dashboard for ML ops. And also for generative AI, this is an evolving area overall. So there's a lot of operations terms that I've seen. There's generative AI, ML ops, and LLM ops, and there's several other areas. I have another slide later if you'd like to dive into that a little bit more. Beyond this, this is my last slide, and then I'll pause for questions. This is that unsuccessful outcome that I mentioned, that the model, for whatever reason, isn't able to achieve that performance threshold. That performance threshold can't be met. So what do you do next? Well, if there's already root cause analysis approaches that you're using, those should be applied here as well. There's like the 5 whys. There could be team brainstorming, for example, to really understand, why can't the model learn well enough to surpass that threshold? And it's just deep diving into those root causes with data science. A couple of things to consider is the data that the model is using, whether it's a supervised or unsupervised model, is it a data quality issue? Are there inconsistencies in the data? Is there a subset in the data that is giving the model more trouble than others? So for example, if we look at like housing data, if we were to produce a model to predict housing prices in the Minneapolis area, there's about 50 different zip codes in the Minneapolis area. Well, is there one data subset, one zip code that's really giving the model trouble? Is it because the zip code has less data? Is it because there's more randomness in that data? And there's actually different tools and packages that could actually be used to determine what subset of that data is giving the model trouble. Another obvious thing to look at is, can more data be obtained to train and evaluate that model? And this means using the humans in the loop, the taggers, to actually provide more of that data. And also to go broad and look for guidance, either within your own companies or even external, to say, are people running into similar issues trying to train the same or similar model? And there's a fourth bullet point that I wanted to add here, that these 3 bullets, they really are within the data science realm. But another one I wanted to suggest is, can that model evaluation metric threshold be updated with the smallest impact to the business opportunity? So for example, the threshold we set earlier was an F1 score of 0.75 or greater. Well, that's related back to the business opportunity we're trying to meet. Well, if the model is performing at, let's say, 0.71 or 0.72, just below that threshold, well, what would it mean from a business perspective if we slightly decreased that threshold down to where the model is reliably performing? Does that mean that we'd have to give out, in the customer churn case, that we might give out more gift cards, for example, and what roughly would that cost be? So this is just an example of, looking outside the data science area to make some modifications, but that's ultimately a business decision to relate adjusting the threshold back to that original business opportunity. So with that, we extended your experience working on regular software projects to include projects with AI. And also we just used that generic software development lifecycle to show where that work could take place. So if there's any questions.
Awesome. Thank you so much. Appreciate that so much. We got a wonderful audience here. Now you can finally see of faces that you've been speaking with. Actually, I'll see if I can just kind of position this so that you can see them. But this was great. Thank you so much, Craig. What type of questions do people have for Craig about your own projects and incorporating AI and ML into your software development lifecycle? Yeah.
So the biggest question I've had is, everybody's talking about large language models, but what does it actually cost to get the training data and run a training from these large language models where you have all the data on premise?
Sure. So question, what's the Toyota Corolla, Camry, and Avalon costs for getting a model trained up and running if you want to use it for an LLM project? So And this is all a lot of variance, I understand, but just maybe some ballpark numbers or some back of napkin math that we can use to maybe think about what would cost for our project.
So there's actually two questions there. I heard one around large language models, and that works specifically with written text. And then I also believe I heard about training cars. So that's more vision recognition. So are those the two questions?
No, that was just training the models, not the cars. Sorry.
So just also training a large language model itself.
Yeah.
Right. If you were to build your own model and train it
Yeah.
effectively.
So it depends on the business context. So for example, if you have a fairly focused amount of text, and let's say that you have a history of, and it's kind of hard to give an exact amount of data, but you'd need tens of thousands, if not millions, of comments from customers, and even interactions with support staff, for example, if you were to train a model to actually help resolve some of those customer support issues. If it's a fairly focused area, the training for that could take months or slightly longer than that. Another approach is to actually use a pre-existing large language model, whether it's ChatGPT or Gemini, and actually augmenting that data that they have. There's this thing called a retrieval augmented generation, RAG is what they call it. And that's where you're actually reusing their model. You're providing your data. It actually gets vectorized in a vector database. And then the original question along with the associated data is provided to that model. And then the response comes back. The risk with that is that you're actually providing your own company data external to the company. So there are some privacy and security risks there that need to be considered. But it's kind of hard to provide a definitive answer on the amount of data, because it depends on how focused the text is and what the ultimate goal you're trying to achieve.
Yeah, that's great. And I think I've tried to start to price out some of these things too, and it's kind of like, if you can understand the amount of text to tokens, and then the cost per token, and then the number of resources, you can start to kind of model things out. So for example, let's say you wanted to vectorize a website, for example, and each web page had 800 words on it. That's about 1,000 tokens. So then you can take your 1,000 tokens times your 1 cent per 1,000 tokens, or 10 cents per 1,000 tokens kind of rate, whatever model you're using. And then you can start to create, a sheet with estimates there. But, to Craig's point, it really is dependent upon the data set, how many you're going to have to use. And in some cases, like with vector databases, it's like, well, how many pieces of knowledge do I need to vectorize? That might be a finite number, so you can create a fixed budget for that. But some things, like what Craig is saying, you don't know how many records you're going to need to put in your model until you've trained it to the appropriate point. So that's where you need to kind of come up with, well, best case scenario, we can train this at this budget. One thing that was told to me as we were building a image classification model was start with a whatever data set you have, a small one. I think we started with like 500 images, and we had like a holdout of a couple hundred images that we could kind of compare or test those and how well the model performed. And then he was like, well, you can train it at 600, but that's like, are you going to get that much incremental performance, or should you wait until you have an order of magnitude more? Like maybe I have twice as many, or maybe I have 10 times as many, and then I'll try to retrain. So I don't know, Craig, would you disagree with any of that, or is that in line with what your experience has been as well?
Yeah, I was actually nodding a lot when you were talking. Yeah.
Okay, perfect. Hopefully that was helpful. What other questions do people have? Arun.
I have a question in general. What's Craig's advice for people to get into this game?
Yeah, what's your advice for people to get into this game?
To get into this game. So like from a project and program management perspective, or data science, or
and say, okay, this seems to be just like a few years ago, we had data prompts. everybody was doing there. Now it looks like AI products, it doesn't have models or whatever. But there seems to be some gaps in knowledge one has to fill to get in there. So what would be Craig's advice on what skills to gain, the courses one has to take, get on experience, etc.?
Yeah, so that's a great question. Let's say you had, a very finite amount of time and wanted to get started or kind of just make some progress here. What courses would you recommend, or maybe topics that people suggest, or maybe even like, are there sandboxes out there that people can jump in and start to, play with API requests or something in a very, friendly way, approachable way?
Yeah, absolutely. So the advice that I always give people is, because AI has such a broad number of applications, there's vision, there's image recognition, there's all text processing, there's even statistical data for doing predictions. I would first pick an area that you are passionate about. Like I said earlier, natural language processing was an area I was very passionate about. Yours may be image recognition, for example. And I suggest that because when you're passionate about something, you're going to dive much more deeply into it, and you're going to learn a lot more about it. Also, when you focus on an area, and you actually start, understanding more about how those models work, what you do to create a model to do image recognition, some of those things are going to apply to other models as well. So there's going to be, cleaning data and converting data and things like that. So I would first pick an area that you're absolutely passionate about. I would stick with it for about 6 months or a year, dive deep as far as you want to go. And along the way, you're going to be learning things that are applicable to other types of machine learning as well.
Great. 6 months to a year. What if I have a weekend? What can I do?
Yeah, that's how I started as well. I was doing work on weekends, and I'm still writing code on Python and over the weekends. I absolutely love it. And there's tons of free online courses as well. There's Coursera, and there's edX, Udacity, Udemy. Some of the courses are very cheap. They give you a cool certificate at the end. The write-up will tell you the level of detail or prerequisite knowledge that's necessary. I think there's a course on Coursera. It was Machine Learning for Everyone, I think is what it's called. And it's actually a very cool course because they go over a lot of the core concepts, but they don't get very much into the math. So,
Yeah.
There's also one thing for machine learning for product advantages. It shows all the linear regression or the mathematical models. It's in Coursera.
In Coursera for machine learning for product managers. Coursera. Good course.
I just did
endorse it.
Generative AI for everyone last week. Trying to take that one. So
That's great.
Yeah.
That's fantastic. Okay. And this is also part of the community here too. Like, what other tips do people have for learning AI and ML quickly? I think, Arun, we might see something from you a little bit later here or very soon, on how people can get started. I think my little hacks, because I'm not a developer, but I've had to do a lot of low-code stuff recently, API requests and that nature, getting access tokens and keys and posts and gets, and I'm using all the language, everybody. So I was using Gemini and ChatGPT to help teach me how to do these things. And so I would go to a documentation page on the API, and they would say, here's what you need to do. And I'm like, no idea what this is. So I put that URL in Gemini, say, well, you got to tell me how to do this. And all of a sudden I would engage in a conversation, and I learned how to, create a service account in my Google Cloud Console with a access token that refreshes every hour now. And we're able to use that to make API requests between our app and our Firestore database, and then use that for routing in our LLM work. So it's, sounds like very daunting, but honestly, it's like what Craig said, the weekend projects, start with a use case, something that you're passionate about. And I would even extend what he said, it might not be an area of ML. It might be something in life that you really care about. So maybe you cook a lot. You want to, vectorize all of your grandmother's recipes or something like that, so you can have Granny GPT. That's all possible, and it's a weekend's worth of work with the source documentation, maybe a video on YouTube, and then using LLM to help you explain the gaps that you don't understand. So that's fantastic. Wonderful. Any other questions for Craig before we let him go? Craig Gotchi, thank you so much for being here
Thank you.
today. We really appreciate it.
Thank you. I appreciate the
If you want-
opportunity.
Yeah, absolutely. If you want to send us your slides, I will take that and the resource. I'll put them online and then I'll add them to the slide deck. So, so that if you don't mind sharing, if they're proprietary, that's fine. But if you want to share, I'll make sure that everybody gets a copy of this.
Okay. Well, thank you. Bye-bye.
Perfect.